All right, everybody, welcome to this explainer video. We'll be looking at application questions with trigonometry and Pythagoras theorem. So let us look at this question number one. What we have here is two right angle triangles stacked on each other. And the question says to find the size of angle PQS. Now, just looking at the top right angle triangle, we realize that we cannot find angle X if we don't know another side. So we need two sides to find an unknown angle in trigonometry. Now, if you look at the bottom triangle, we realize that we have a reference angle and a side. So we're going to use the reference angle and the side to find SQ. And we're going to use trigonometry to do that. But before we do that, you see, let us label the triangle. So any side opposite the right angle is called the hypotenuse. And any side that's between the reference angle, 65, and the right angle is called the adjacent side. And the remaining side would have to be the opposite because it's opposite the 65. But sometimes opposite can be tricky. So I suggest students to work out the H and the A because those are two foolproof methods of getting H and A. All right, so since we have labeled the triangle, we need to determine which trigonometric ratios we're going to use. Is it sine? Or is it cos? Or is it tangent? And we're going to use the acronym SOHCAHTOA. So I always tell students, look for what you have. What do we have? We have A, which is the adjacent. All right, so clearly sine is out because sine don't have no adjacent. Now, which side do we want? Do we want H or do we want O? We want O. So which trig ratios have O and A in it? Yes, you are correct. Tangent. So we're going to use tangent. All right. Well, let me just explain further. Once we use the tangent and find SQ now, we're going to use SQ and PQ to determine the size of angle X. So tan now, let us zoom in this a little bit. All right, so we agree that we're going to use tan. Now, tan is opposite over adjacent. So the numerator would have been SQ and the adjacent side would have been 3. Now to find, you realize that the only thing we don't know is SQ, which is the side that we want to find. So what we do, we multiply both sides by 3. What happens is that these two 3's here will cancel out, leaving SQ is equal to 3 tan 65. 3 tan 65 turns out to be 6.43 centimeters to 3 centimeters. So ladies and gentlemen, SQ is actually 6.43 centimeters. So now that we have this side, SQ, we're going to use SQ and PQ to work out the side of angle SQP or PQS. But before we do that, ladies and gentlemen, let us identify the different sides. So obviously 10 would have been the hypotenuse and SQ would have been the adjacent side and PS would have been the opposite side. So what happened is that we need to determine which trig ratio we're going to use to find X. So we have sine, we're going to use the SOHCAHTOA acronym. Now, because we want to find an angle and we want two sides, is what we have, don't you? Now, do we have A? Yes, we'll just work it out. Do we have h? Yes, it's 10. So which of these formulas have a and h in it? It's cos. So we're going to use cos. All right, let's quickly view how it has been done. So part 1 of the solution is to find SQ. Part 2 of the solution now is to work out the actual angle. So we determine that cos we're going to use. So cos is adjacent, which is 6.43, divided by the hypotenuse, which is 10. And we find inverse of that, and we get 50 degrees to 1 decimal place. Let's quickly look at another question. Oh, one thing to mention that these diagrams are not drawn to scale. Sometimes just some students will go in an exam and test, and they take out the ruler, they take out the protractor. Because the question is just to find the angle x, you might just take out the protractor and just measure it and say, so see there. But that's incorrect, because the diagrams are not drawn to scale. So in this diagram, we have another triangle stacked on the other one. We have two right angle triangles. And the question says to find side AD or X. Let us examine. Apart from the fact that it's two right angle triangles. So the thing about it, we're only given one reference angle down at the bottom triangle. So in order for us to find X, because based on what I'm observing, there's no way we can actually find a reference angle in the top triangle. We can find another side. We can actually work out side AB using 47 as a reference angle and 3.7 as a side. All right, which is what we're going to do. Now, after you find AB, ladies and gentlemen, you realize that with Pythagoras, if you're given two sides, you can find the other side. So that's what we're going to do. We're going to use trigonometry to find side AB with information at the bottom triangle, which is ABC. And then once we get that information about side AB, we use Pythagoras theorem to find the missing side. All right. But before we can do that, ladies and gentlemen, let us label our diagram, because we need to know which trig ratio to use to find AB. So obviously this is going to be the hypotenuse because opposite the right angle, and 3.7 would have been the adjacent, and AB would have been the opposite side. Now, since we want AB, which is O, so we want O and we have A. Which formula have O and A in it? Yes, you are correct. It is tangent. So we're going to use tan. All right, let's quickly scroll down for the solution. All right, so tan 47 now, which is the reference angle at C. Tan 47 is equal to the opposite, which is AB, which is what we want to find out, divided by the adjacent side, which is 3.7. So what we do is to multiply both sides by 3.7. These two 3.7 will cancel off. So AB is equal to 3.7 times tan 47. And that turns out to be 4 meters. So A to B is actually 4 meters. So now that we have the two sides, we're going to use Pythagoras now to find the other side. So let's do that now. So according to Pythagoras, this is his theorem. The sum of the squares of the two short sides is equal to the square of the longer side. So if you add the squares of the two short sides, well, by the way, the hypotenuse is the longest side, right? So if it's a triangle and you have three sides, and I say, okay, one of them, the hypotenuse is always the longest one, then the other two sides must be the two short sides. So Pythagoras says the sum of the squares of the two short sides is equal to the square of the longest sides. So AB, which we just worked with a while ago, is 4. So it's going to be 4 squared plus x squared. X squared is what we want. X is what we want to find, is equal to 55. And we subtract 4 squared on the left, 4 squared on the right to balance the equation, and also to get rid of 4 squared because we want x. So x squared is equal to the difference between 30, 25, and 16. And that is actually equal to okay, there's a little typo here. Yeah, there's a little typo here. So let me just correct it. So 3025 subtract 16 is actually 3009. So that shouldn't be there. My apologies. That should be 3009. And then what we need to do now is to find the square root of 3009. That turns out to be 54.85. So the answer is actually 54. Well, if it's one decimal place, it's actually 54.9 meters. And we square root the left and the right to get rid of the x squared. So ladies and gentlemen, x is actually equal to 54.9. Thank you so much for joining. I'll see you around.